let's complete the square in a couple of easy steps. We want to try and get our quadratic, right, into this expression here. So something squared equals something else, okay? Pretty nice. The first thing we have to look at is this section here. That's what our eyes are drawn to. And it's this that tells us what we're going to put in our squared here. The only way to get our x squared is to have the x in there. And this 8, we're going to halve. We're going to pop in the 4, right? Halve, divide by 2. And we're doing that because we know that when we have x plus 4 squared, we know this means x plus 4 times x plus 4, right? And we do our normal expansion stuff, and we end up with x squared plus, we've got a 4x plus another, right? So over here we get 4x plus another 4x underneath, so that gives me 8x, and then we've got 4 times 4, which is 16. And I can keep doing this all day, every day, even if we do, how about we go minus x take 6 squared, right? That's going to be x take 6, x plus 6, and if I expand that, x times x gives me x squared, x times, oops, that should have been minus, got a bit carried away there, x times minus 6 is minus 6x, then I get another minus 6x, so that's minus 12x, and a negative times a negative, it gives me a positive, and 6 sixes are 36. You can start to see just from 2, right, there's a bit of a pattern here that 4 times 2 gives me the 8, and then 4 squared gives me this 16. So if we then have what we've got here is 8, we halve it and we get the 4. As we said over here, when we expand, we're very happy that we get the x squared, we get the 8x, but we also get this plus 16. So to keep everything nice and even, because we've added 16 to the left-hand side, we're going to add 16 to the right-hand side. And you're pretty much done, except for this plus 3. That needs to go over to the other side as well, and to get rid of the plus 3, we're going to do the opposite, we're going to take 3. Now it's just a matter of, let's tidy things up. The left-hand side stays the same, but the right-hand side is now 16, take 3. Last time I checked, that's 13. We're trying to get x by itself here. If I read this, it's x plus 4 squared, so the last thing I said was the squared, so that's what we're going to undo. And we know that we undo a squared by, yep, you've guessed it, we square root. We just have to remember, when we square root a number, it can be a positive or negative, because positive root 13 times root 13 gives me 13, and negative root 13 times a negative, right? Negative times a negative gives me a positive. So we're down here, and last but not least, we just finish off and we say x, to get rid of this plus 4, on the other side, it goes minus 4, plus or minus root 13. Okay, if you really wanted to check what we do, remember this means you've got two solutions. It's minus 4 plus root 13, and it's minus 4 take root 13, but I don't want to write it out like this. I just leave it in that form there, right? Short, sharp, shiny, all done. Now remember, the whole reason we were doing this is to find values for x that when we substitute into this expression here, it will make it true, so it will make it equal to 0. And a way to check would be that we could substitute this back in, so you could take minus 4 take root 13 and square it plus 8 times that plus 3, and lo and behold, it will give you 0. Another way is to really earn your keep with these graphics calculators. So we're going to go down. So if you're not in menu, go to menu, and then we're going to use our arrow keys and go down here to equation, and we want polynomial. So you can see polynomial is F2, so you press F2. It's degree 2 because, right, well, you think about it. Why do you think it's degree 2? Any clues to us? Right, x squared, degree 2. And we're going to pop in, so if we look over here, it says ax squared plus bx plus c. So a is your number in front of x squared, b is your number in front of x. So we go back over here, and my number in front of x is a 1, b is 8, c is 3. So 1, 8, 3. Let's see if I can remember that. 1, enter, 8, enter, 3, enter. Okay, you can either press enter again, oops, or you could have pressed solve. And you can see here we get minus 4 plus root 13 and minus 4 take root 13, and that's pretty much what we got over here. Just a heads up, if you're using a slightly older calculator, it won't give you the exact answers here. So that's where these newer ones really help you out. So let's just do one more if you need to. If you don't need to, please feel free to go to the worksheet and complete those questions that I've asked you to do. Okay, so here's one more. We look at it. Remember, the quickest way to solve quadratics is to factorize, but we can see very quickly there aren't two numbers that times together that would give me minus 2 and at the same time add up to minus 10. It's just not possible. So what we instead do is we look at this here, specifically the minus 10, and we're asking ourselves, okay, let's halve that because that's what will go into our bracket. So it's x minus 5 squared. And that's when we have to now remember, when we expand x take 5 squared, we end up, I'm going to do the long version again, but I'd like to think that we are getting really familiar with expanding brackets. So x times x is x squared, especially perfect squares. X times minus 5 is minus 5x. We get another minus 5x here, so minus 5 take 5 is minus 10x. And then negative times a negative is a plus 25. So by writing this bit here as x take 5 all squared, we've actually added in this 25. So remember, to keep life happy, we add 25 to the other side. We can't leave it there because we have to get rid of this take 2, so we're going to plus 2 because we're moving it over to the other side. Simplify. So we've now got 27, and your job is to get x by itself. So let's get rid of that squared first. Opposite of squaring, square rooting. And yep, you remembered, put the plus or minus 27. And to get rid of the take 5, we're going to add 5. So put the positive 5 there. At this point, you are done and dusted. Those who want to push it just a little bit, okay, if you want to go for that extra yard, you can simplify this a bit. So when we're looking at root 27, okay, in fact, if you put it into my calculator over here, and we go root 27, it gives us 3 root 3, okay? Why is that? Well, mathematicians think that if you use smaller numbers, it becomes more simple. So in order to simplify a square root, also known as a surd, we have to look for these square numbers that could go into it. So 4, 9, 6, 25, 36, etc. Why are these square numbers? Because I know the square root of them. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is so on. You get the gist. So you have to ask yourself, do any of these go into 27? Okay, I hope you will see that yes, 9 does. So one of the rules of maths says I can break this up. This is going to be 9 times 3. You all agree 9 3s are 27. And that means I can separate that to be root 9 times root 3. And why did we do this? Because the square root of 9 is 3. So that becomes 3 times root 3. So if you see this like this, they're the same. But you don't have to do this next step. If you want to leave it like this, all good. Happy as Larry. So what I'd like you to do now is come back. Okay, see if you can now do these questions here. And remember, you can use your calculator to check. So remember, you go into menu, down we go into equation, we put polynomial, degree 2, and if we go back to this worksheet, I can already check this one. So 1, 10, 15. So we go back over here, 1's already there, use my arrow key, 1, 10, 15, and we're hoping that when you do the complete the square, this is the answer that you get. All right, so give that a go. Go back, follow the example that we have here. All right. Hope that is helpful to you.